Welcome to section 4.5. We're going to be talking about graphing the sine and cosine functions. Now, when we talk about the period of a function, that's the length of the smallest interval that contains exactly one copy of the pattern of the periodic function. So when we talk about in one period, it's one full pattern in the graph. So now, when we graph the sine function from the unit circle, if you have your unit circles, if we think about our key points, we have our values for theta, and then our values for the sine of theta. So when theta is 0, our sine is 0. When our value for theta is pi over 2, we're at 1. When theta is pi, we're at 0. And when theta is 3 pi over 2, the sine is negative 1. And then when we get back to 2 pi, when we get to the next circle, we're back to 0. Now, the way that sine works, we have our 0, our maximum, 0, the minimum, the lowest point, and then back to 0. And it's just going to keep following that repeating pattern. So what we would do, here's our pi over 2, pi, 3 pi over 2, and our 2 pi. This is the beginning of our next circle. So that's our x-axis, and our y-axis we have our 1 and our negative 1. So what we're doing is we're going from 0, 0, pi over 2 we're at 1, 0, pi we're at 0, 3 pi over 2 we're at negative 1, and 2 pi we're back to 0. So one period of the sine graph looks like this. That's one period. Now, we can also go backwards. Negative pi over 2. Negative pi. Negative 3 pi over 2. And negative 2 pi. Now, those values, remember, negative pi over 2 is the same as 3 pi over 2. Pi is the same as negative pi. Pi over 2 is the same as negative 3 pi over 2, and 0 is the same as negative 2 pi. So the outputs would be the same. Negative pi over 2, that's negative 1. Negative pi, we're at 0. Negative 3 pi over 2, we're at 1. And then negative 2 pi, we're at 0. So what two periods would look like is this. And you see how it just kind of looks like a wave? That's what the sine curves look like. Here's one period, is between 0 and 2 pi. That's one full trip around the unit circle. Now, for the sine graph, our domain, we can use any input we want to. It's going to go from negative infinity to positive infinity. But all of our outputs, our range for the sine of x is going to be from negative 1 to positive 1. Now, sine is symmetric to the origin. It has origin symmetry, which means it's an odd function. And as a refresher of what an odd function is that f of negative x equals negative 1 times f of x. So what that means is that the sine of negative pi over 2, can't talk, equals negative 1 times the sine of pi over 2. And if you look at the curve, at the graph, the sine of pi over 2 is 1. The sine of negative pi over 2 is negative 1. So you can see it's negative 1 for the sine of negative pi over 2, which is negative 1 times 1. So negative 1 equals negative 1. That's what it means for it to be odd. When you evaluate the negative, it's going to be -1 times whatever that positive angle would be. So you want to think about the pattern for sine, 0 max, 0 min. That's how it works. Now cosine is actually very similar. From the unit circle, we have our key points. So our key points would be the same as 0, pi over 2, pi, 3 pi over 2, and then back again to our beginning of 2 pi. So now, the cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is -1, and the cosine 3 pi over 2 is 0, and the cosine of 2 pi, we're back to 1. So the way this pattern looks for this one, we have our pi over 2, pi, 3 pi over 2, 2 pi. On our y-axis are 1 and our -1. So when we look at it, when theta is 0, we're at 1. Pi over 2, we're at 0. Pi, we're at -1. 3 pi over 2 is at 0. And 2 pi, we're at 1. So 1 period of cosine looks like this. Now if I go backwards to see another period, here's my -2 pi, -3 pi over 2, -pi over 2. So once again, 2 pi is the same as 0. 3 pi over 2 is the same as -pi over 2. Pi is the same as -pi. Pi over 2 is the same as -3 pi over 2. And 0 is the same as -2 pi if we go clockwise. So once again, if we're at -pi over 2, we're at 0. -pi, we're at -1. -3 pi over 2, we're at 0. And then for -2 pi, we're at 1. So if we draw another period, it looks like this. So one full period between 0 and 2 pi, that's one period. That's one time around the unit circle. Our domain is just the same as it was for sine. It goes from -infinity to infinity for our inputs, and our range goes from -1 to 1. Now, cosine has y-axis symmetry. If you were to fold this graph along the y-axis, all the parts would line up, which means it's an even function. And as a refresher, what the even function means is that f of -x equals f of x. So for example, the cosine of -pi equals the cosine of pi. And you can see the cosine of -pi is -1. The cosine of pi is also -1. That's what it means for it to be even. When you take the cosine of the negative angle, you get the cosine of the positive angle. And if you look at the sine and cosine graph, sorry, it's a little bit, and we'll look at that on the next page actually. If you look at the sine and cosine, if you were to extend them, if you were to go backwards, this one's actually a little bit better. If you were to pull this and shift the sine curve to the left, it would actually show you the cosine curve. And they're so related, except cosine goes 0 max, 0 min, 0. It starts at 0, it goes to the max, to 0, to min, to 0. There's a sketch of the sine and cosine for you. Now let's see what happens if we put a number in front. That number in front is our vertical stretch. That affects what's called our amplitude. Now, that means our amplitude is 2. That's going to be our highest, and then negative 2 would be our lowest. So when we sketch, I'm going to draw a coordinate plane real quick. So here's my pi over 2, my pi, 3 pi over 2, 2 pi. And once this go to 4 pi, so I got my 5 pi over 2. Just keep adding a pi over 2. I have my 3 pi, 7 pi over 2, and then 4 pi. And it wants us to go back. So there's my negative pi over 2 and my negative pi. Now, I keep it simple. I know that for sine, I'm going from 0 to the max to 0 to min back to 0. So what do I mean by that? My max is 2. My min is going to be a negative 2. I start at 0. Then I get to my next key point, pi over 2. I'm at 2, my maximum. Back to 0 at pi. To my minimum, negative 3 pi over 2. I'm at negative 2. 2 pi, I'm back at 0. Then I go max, 0, min, 0. And its sketch looks like this. Here's one period. And now this would be a second period after that. That's 2 periods. And I can even go backwards. Just going to follow the same, but I go backwards. So I'm going to be at my minimum and then back to 0. That's what this graph would look like between those 2 points. And you can see if I were to sketch just sine of x, you can see it's stretched out vertically. There's that vertical stretch. There's that vertical stretch. So just make a note that the range, this time because we increased our amplitude, negative 2 to positive 2. So when you think about sine, think about the pattern 0, max, 0, min, 0. We're going to be doing more practice of this. Those are our key points. Now for 3 cosine of x, we have a vertical stretch. Now our amplitude this time is 3. That's our highest and lowest values. So here's my pi over 2, my pi, 3 pi over 2, 2 pi, 5 pi over 2. I'm just adding a pi over 2 each time. Then it's 6 pi over 2, which is 3 pi, 7 pi over 2, and then 8 pi over 2, which is 4 pi. And then we'll go backwards to a negative pi over 2 and a negative pi. So now, unlike sine where we go 0 max, cosine goes max, 0, min, 0, max. That's the pattern it follows for our key points. So we're starting at 3, 0, negative 3 for our min, 0, max. That's one period. Then we just keep going. It just keeps repeating back to 0, to the minimum, to 0, back to the maximum. Here's our second period of cosine. And if I go backwards, I'm at 0 and then the minimum. So that would be basically 2.5 periods there. So just take note, the range this time goes from negative 3 to positive 3. That's amplitude. Amplitude just changes our highest and lowest points. Okay, I'll see you in the next video. We'll talk more about these.